All right, now we look at this problem on the discrete distribution. And we know that x is a discrete random variable, only taking on values from 1 to 5. And the distribution is given this table. So we can see that when x is equal to 1, the probability is equal to 0.2. And when x is equal to 2, the corresponding probability is equal to 0.15. And we can also find the probabilities of x equal to 3, 4, and 5 on this table. But we can see that when x is equal to 5, its probability is equal to y. So our first job in this problem is to find the value of y. That is the probability of x equal to 5. Remember, the probabilities in the discrete distribution satisfies two criteria. The first one is that all the probabilities p sub I are greater than or equal to 0 for all I. And the second, if we sum all the probabilities, that is, sum pi from I equal to 1 to n, and here we have n equal to 5 because we only have 5 different values. And we must have the sum equal to 1. So here we're going to use the second criteria to do this problem. Then we know that the sum of all the probabilities, that is all the probabilities, must equal to 1. That means we will have 0.2 plus 0.15 plus 0.35 plus 0.05 plus y equal to 0. Oops. And then if we do the algebra, and we can see that y is equal to 0.25. Okay, so this is the probability when x is equal to 5. Now let us go to the second portion. And in this part, we want to find both the mean and the variance of this random variable x. And remember, the formula for the mean is given by a weighted sum, that is xi, where I goes from 1 to n, and here n is equal to 5, times the probability when the random variable x is equal to the small xi. Okay, so here our xi can be equal to 1, 2, 3, 4, and 5, and we have 5 distinct values. So just like what I said earlier, n is equal to 5. All right, so let's plug in numbers into this formula. We will have when xi equal to 1, its probability is equal to 0.2. So here 1 is our small x1, and this number 0.2 here is the corresponding probability. Okay, and then we plus x2 is equal to 2, and the corresponding probability is equal to 0.15. And we do the same thing for xi equal to 3, and we multiply it by its corresponding probability, that is 0.35. And then we plus xi equal to 4, and times its corresponding probability, that is 0.05. And finally, when xi is equal to 5, the corresponding probability is y, but we find that it is actually 0.25. If we do the algebra, we can find the mean is equal to 2. Okay? No, it is equal to 3. Sorry. Alright, then we go to the variance part. Remember the variance I will use this notation. Variance x is given by a weighted sum from I equal to 1 and then to 5 times small xi minus the mean which we got from the first part, then square times the probability of capital X equal to the small xi. Okay, so if we plug in the numbers, we can see it is equal to when xi equal to 1, that is 1 minus the mean 3 square, times the probability when x equal to 1, that is 0.20. And do the same thing for 2, that is when xi equal to 2, 2 minus 3 square, times the probability when x equal to 2, that is 0.15, plus xi equal to 3, 3 minus 3, times the corresponding probability, that is 0.35, plus when xi equal to 4, 4 minus 3 square times the probability of x equal to 4 times 0.05, and finally when x equal to 5, we have 5 minus 3 square times the corresponding probability, that is 0.25. And then if we do the algebra, we can see the variance of this discrete distribution, this discrete random variable x is equal to 2. Okay, this is the second part where we find the mean and the variance of this discrete random variable x. And then we go to the third part of this problem. We want to find the probability of this x greater than 2 and less than or equal to 4. And in some mathematical expression, we can see it is actually p 2 strictly less than x, and then x is less than or equal to 4. Okay, so we can rewrite this expression to less than x less than 4 as, because this x is a discrete random variable and it can only take on values of 1, 2, 3, 4, and 5, and here we want to find the probability when x is strictly greater than 2. That means we cannot have 1, we cannot have 2, but we can have 3 because 3 is greater than 2. X can equal to 3, and x can also be 4 because we can let x equal to 4. But we cannot let x equal to 5 because 5 is greater than 4. So basically, if we want to find the probability of x greater than 2 and less than or equal to 4, we're looking for the probability of x equal to 3 and x equal to 4. Because x equal to 3 and x equal to 4 is a disjoint event, so by the probability rule, we can rewrite this expression as the probability of x equal to 3 plus the probability of x equal to 4. And because when x equal to 3, the probability is 0.35, and the probability of x equal to 4 is 0.05, we can see the resulting probability is equal to 0.40. So this is the answer for this part. Alright, now let us look at this fourth problem in this problem set number 5. So we want to find the probability of x equal to 4 given x greater than or equal to 2. So basically, this is a conditional probability. Okay? So remember, the formula for the conditional probability is given by the probability of A given B is equal to the probability of both A and B occurring divided by the probability of B occurring. So here basically B is the event X greater than or equal to 2, and the event A is X equal to 4. Okay? So I will write parentheses here to represent these two are events. Alright. So I will firstly express the problem in some mathematical expression. That is, we want to find the probability of X equal to 4 given that X greater than or equal to 2. And we know that this is equal to the probability of X equal to 4 and X greater than or equal to 2 divided by the probability of X greater than or equal to 2. So now we need to find both the numerator and the denominator. For the numerator, we can see that it is a probability when X equal to 4 and X greater than or equal to 2. But 4 is already greater than or equal to 2. So we can rewrite the numerator as the probability of X equal to 4. And for the denominator, it is the probability when X greater than or equal to 2. So just like what we did in the third part, it is equal to the probability of X equal to 2 plus the probability of X equal to 3 plus the probability of X equal to 4 plus the probability of X equal to 5. Okay? So if we look at the table of this distribution X, and we know that the numerator is equal to 0.05, and if we add the probabilities in the denominator, it is equal to 0.8. And if we do the algebra, the resulting probability is equal to 5/80, and if we simplify it, it is equal to 1/16. Okay, so this will be the final result of this part.